Good afternoon. On behalf of Engineers Australia, I'm delighted to welcome you all to today's webinar, Efficient Design for Better Timber Buildings. My name is Amanda and I'll be your host for today. Firstly, in keeping with our custom, Engineers Australia acknowledges the traditional custodians of the country throughout Australia and recognises their continuing connection to land, waters and community. We pay our respects to them, their cultures, and to elders past and present. Before we get started, I'd like to acknowledge that today's webinar is being hosted with Engineers Australia's industry partner, Wood Solutions. Wood Solutions is a non-profit initiative established in 2010 to provide independent technical information on timber and wood products for building professionals. Supported by Forest and Wood Products Australia, it offers comprehensive resources, including case studies, technical publications, and design guides to promote timber use in construction. Wood Solutions also hosts seminars and workshops to foster sustainable and innovative building practices. Its mission is to help architects, engineers, and other professionals make informed decisions about timber, contributing to the growth and development of the design and build sector. Today, we will hear from our speaker, followed by a live audience Q&A, and I encourage you to send questions through to our speakers via the YouTube chat box. I'd now like to welcome our first speaker for today, Nick Hewson, Director from Arboralis and Wood Solutions. With over 18 years of experience in the construction industry, Nick is a chartered structural engineer and timber engineering expert. He has led diverse projects from domestic renovations to multi-billion-dollar civil and structural developments in the UK and Australia. As a director and founder of Arboralis, a consultancy specialising in innovative timber solutions, he is passionate about promoting timber's role in a low-carbon future, and he has co-founded Timber Dialogue, a community organisation supporting timber use in Australian construction. Nick has a strong background in engineered wood products and structural dynamics and has contributed to multiple publications on timber design. Please welcome Nick Hewson.
Thanks very much for the introduction. It's wonderful to be here to talk to you today around the subject of DFMA and timber on behalf of Wood Solutions. Just want to quickly introduce myself. Nick Hewson, Director of Arboralis, which is my own business focused on timber structures. I've been practicing as an engineer for 20 years, just checked over my 15th year in Australia, having originally started my career in the UK. And I've worked on a number of buildings across the world utilising timber structures, whether that's mass timber or lightweight framing, and really pleased to be given the opportunity to chat to you today. Quick look at the agenda. I just want to kind of say a few words about Wood Solutions. I'm here representing them today. I'm going to talk a bit about DFMA, what is it, and some of my top tips and experiences to show you better how to design your buildings to be more tuned to the way that we want to manufacture and to build, to make them cheaper, make them more cost effective, and ideally build some more timber buildings. So we'll get underway. So as I said, Wood Solutions, they're a not-for-profit company resourced by FWPA, provided for through government funding and levies from the use of timber in Australia. So their remit is to provide information, independent support to people, engineers, clients, architects, builders who are interested in timber structures. And it's a wonderful organisation, and they do a lot of really good work. If anyone's been to their website, if you haven't, I encourage you to go. They do a lot of technical design guides. There's 60 or more of them now, covering everything from domestic decking up to mass timber towers. They also have a project portal, which goes through a number of different projects, both in Australia and overseas. So if you're looking for inspiration looking for examples to provide clients to see what's possible. It's a really great resource. So why are we so passionate about building with timber? It's a sustainable and renewable resource that stores carbon for its life cycle. Half the dry weight of timber is carbon, and using more timber in our buildings, we can offset carbon footprints from the running costs of the building, and it's an incredible material, and we want to try and encourage more use of it to help our efforts to combat climate change. Also has a lot of benefits in improving well-being for occupants of the buildings, and there's some really good resources around that. If you look through the Wood Solutions website, there's some wonderful studies that delve more deeply into that. What I want to talk to you today is DFMA, and why is that important, particularly when we're looking at timber buildings. I wanted to start with a couple of quick definitions. So for those of you who are sort of new to the timber space, we have a range of new products which have come online, some of them fairly recently. Cross-laminated timber, or CLT, is a large format panel with softwood layers and alternating directions. So it kind of creates these large planks. We kind of refer to it as like tilt-up timber. Or it's a big, solid, monolithic panel used for floors and walls and roofs. And that's been one of the ones that has really kind of led the way in the last few years in terms of enabling bigger and more ambitious timber structures. Glue laminated timber, or GLT, has been around for a lot longer, but it's still kind of, together with CLT, it's becoming a really common material, particularly for sort of commercial developments. And then we have LVL, or laminated veneer lumber, which is a peeled product, effectively a kind of plywood on steroids, effectively. And that's another kind of product that we can use to make much larger engineered buildings. So these three sort of form what we sort of broadly term mass timber. And then when you kind of look at your traditional timber, what a lot of lay people in Australia would understand by timber construction is your lightweight framing. So standard sawn timber delivered in individual packs, or pre-nailed roof or wall trusses, roof trusses, and that's primarily being used in Australia for housing or low-rise commercial. And increasingly now we're seeing more people kind of coming on board that are doing lightweight timber prefab or kit parts. So taking that timber frame and adding more elements to it, turning it into walls, pre-installing windows, cladding, and the like. So this is sort of where the industry is starting to move to as we start to adopt modern methods of construction and sort of more prefab. So design for manufacture and assembly. That's really what we're here to speak about today. It's exactly what it sounds like. It's divided into two components: design for manufacture. How do you design your buildings, your products in a way that makes them cheaper, less expensive, less complicated to manufacture? And design for assembly, which is how do you make things easy to put together on site, safe, fast, less prone to errors. I often kind of think of these two as being kind of in balance sometimes. Like there are certain projects which will really benefit from a lot of focus on the assembly part, and it's worth paying the extra time to make the manufacturing. Maybe gets more complex, but if it makes the assembly part easier, then that's worth it overall to the project. So sometimes you need to play these two off against each other, because what may be simple to manufacture may be more expensive to assemble, and it's something you need to kind of understand on a project by project basis, and we'll show some examples a bit later. But my experience of DFMA has been that we often see it as a linear process, and you start with a design, you start with then you go to manufacture, then you go to assembly. But what I'd really like to kind of emphasize is I think we need to treat this more as a circular process, where we can feedback, that we have the ability to all interact to help make your buildings more successful. So one of the things I'm always really keen to do on any projects is to ask for feedback from the manufacturer, from the assembly team. What was easy, what was hard, what could we do better next time? And I think that's a really key aspect to this process. We'll take a bit of a deep dive into manufacture and some of my tips. I will say that the focus here is primarily around mass timber. That's where a lot of my experience has been, but a lot of this thinking equally applies to timber framing and prefab, and we'll touch a little bit on that later. So when you're thinking about design for manufacture, the thing to understand is it's all about volume through the factory. The factory wants to be able to get as much material out every working day as they can. So that's their primary focus. So what you need to understand when you're thinking of a factory is they're often very linear processes. So this is a sort of a schematic of a CLT production plant. So you have material coming in at one end and fully finished panels coming out at the other. So if you have a number of different processes in there, from selecting the material, cutting, finger jointing, planing to size, pressing up the panels in the CNC machinery, if there's a block in any one of those at a particular point, then that can really slow down the whole process and makes the thing a lot more costly. So one of the things we really focus on, particularly in that sort of mass timber space, is what happens at the end of the process, because that's where the really kind of variable elements come into play. There's a lot more opportunity there. Some of my top tips. So number one, top tip, design for manufacture: engage with the suppliers. We can't really get away with that at the moment. There are a lot of different suppliers. It's still relatively new in the mass timber space, in particular in the market. So there's a lot of there's a lot of really good knowledge out there, but every supplier kind of does things slightly differently. They have different materials, but the capability is changing. So just because you dealt with a glulam supplier one year, you kind of assume that they can still do the same thing the next year. Their capabilities are always growing and changing. Materials are changing. So one thing I kind of see a lot is we have a range of different timber grades and glulam grades and things in our standard. Just because they're in the standard doesn't mean they're available. It's always worth checking with the suppliers what's available. I've had a number of projects I've seen where people have kind of designed in the highest grade, only to find that it's not available in the sizes or the quantity that they need, or it's too expensive, at which point you've kind of locked in depths and spatials and things, and you have to work very hard to try to kind of unengineer that. So that engagement with the market to make sure that we're specifying the right things is absolutely crucial. So we need to take into account individual manufacturers' capability. So how long, how wide, what sort of sizes they can make the elements, whether this is a locally sourced project from Australia or whether it's from Europe. Need to make these decisions early in the process, because these can lock in a lot of decisions around structural grids that become very, very important later on. Transport's obviously a big challenge. You can make a big beam or a big CLT slab, but you need to be sure that you can get it to site. So in general, I'm trying to rely on, for floors, potentially a kind of 12 by 2.5 meter size as a largest panel. But in general, it's not actually that difficult to get up to 3.5 meter wide loads to a lot of sites. But that will depend particularly on the state, on the site in question. The general rule of thumb that I have is that the larger piece you can get in, the cheaper overall it's going to be. When you're looking at overseas procurement, you're very limited to the size of a shipping container. So a standard shipping container has a kind of just below 12 meters by about 2.25 meter internal size that you could fit in as a CLT panel. So then that may set out the dimensions for your building, making things more effective. For instance, there's not a lot of sense trying to build a CLT building that has a 6.5 meter floor span, because you won't be able to double span planks over it. You won't be able to get a 13 meter plank. So, small decisions like that can have big consequences later. But certainly for some of the really large ones, some of the glulam there, that's a picture of being delivered for Adelaide Aquatic Centre, which was nearly 40 meters long. The European suppliers have a lot more capability to do those much larger elements. Tip number 2, to rationalize sizing and thickness. Every time you change the size or thickness of a panel, it costs time. The factory needs to kind of recalibrate machineries, change feedstock. The amount of waste potentially increases because you're trying to kind of fit a lot of different sizes in. So this was an example of a project I schemed very, very early in my career. I thought I was doing the engineer thing of trying to optimize material and make everything that the thickness it needed to be. Actually, what we found on that was it was a lot more cost effective to rationalize that to a couple of sizes, because we ended up with a lot less waste on the building. It was a simpler process to install, simpler details. So often you're trying to kind of find a balance between what's the sort of worst case design and what's the what's the most efficient to manufacture. So another element there is if you're making a lot of small panels, that can cost a lot of time. Every little small panel that gets cut out of a big CLT billet takes a lot of time, takes a lot of machine processing time and manual handling. And I will show you an example of where I got this spectacularly wrong on a project. I'll show you a bit later on. Tip number 3, simplifying the details. So much of the cost of mass timber is in the kind of CNC cutting, the processing, that side of it. As I mentioned earlier, like the volume of wood doesn't necessarily change too much, the adhesive, all the other parts, but if your details are very, very complicated and time consuming to manufacture, then that can have a huge impact on the overall cost. So just as an example, here's a couple of details for a CLT wall plate landing on a concrete slab. The top one, as you can see, it's got a lot of different elements in it. It's got rebates, it's got drillings, it's got like a fillet for an angle plate to be pre-bolted down to the slab. It needs the panel to be turned over. There's a lot of different tools. So every time the machine has to change a tool to use a different cutting element to make that, becomes more costly. The detail at the bottom, far simpler, can be done with a simple router and a saw. It needs a little bit more work on site around the base fixing, but there's a significant saving there in cost. And the general rule of thumb I have is, the more difficult it is to draw, the more lines, the more elements you have in a drawing there, the more costly it's likely to be to manufacture. So, bearing that in mind, I think keeping details simple is absolutely crucial to ending up with a cost-effective project. As I said there, cutting to both sides of a CLT panel is very difficult. If you can design your details such that everything can be processed from one side, it's far, far more cost effective. The reason for that is every time you need to process something on the underneath, you have to take the panel off, flip it upside down, put it back on, recalibrate the machine. So that has a significant time impact, which then equates to cost. So again, your details, if they can be machined and done from one side, that's obviously absolutely ideal. Glulam has less kind of requirements there, but it's still engaging with the supplier, understanding what their capability of machinery is very crucial. Tip number 4, maximizing element sizes. So larger elements are often cheaper, particularly looking at something like CLT, but again applies to other glulam and lightweight frame prefab. This was an example I ran of a wall for a project where there were large window openings, and was it going to be cheaper to build it out of 7 separate panels, or was it easier to kind of make the larger panel and cut the windows out? So as you can see, the one on top, there's more timber in it initially, more waste, But as you can see, as we sort of went through the process, it takes a lot less time to cut, takes a lot less crane operations. The material cost is effectively lower, even though there's a higher volume of timber used initially. Because we're not having to kind of do a lot of manual handling and a lot of cutting and taking a lot of time to cut it on the CNC machine. And additionally, it's a fair amount easier and faster to install on site. You're lifting up one panel as opposed to 7. It's not to say that this is going to suit every project. Certainly, there are some projects where it would be more cost effective potentially to do the other one, where you're limited by craneage or access or something. But in general, trying to maximize the size of the pieces we can get to site is going to result in something cheaper. But having a look at that last example, there are other opportunities to potentially not use CLT in those examples, whether you could use glue lamppost and beam or lightweight timber framing, so that you're actually utilizing the timber fiber where it's most effective. It's always sort of something I look at when I'm considering timber buildings. If we want to use CLT, it works really, really well where it's a big solid panel with not too many openings in. The more holes and things you start to cut in it, the more effectively that panel costs per square meter. So where we can utilize that timber fiber in its most effective orientation and work it hardest is often going to be more cost effective. So just sort of following on from that, on that sort of lightweight timber framing prefab, this is becoming more and more common in Australia. It's going to be too hard for me to try to explain all the different ways and mechanisms of doing that, because everyone's process is very new and very different. But there's certainly a number of suppliers out there operating in this space who are very, very capable of delivering into commercial projects. But as I said, everyone's got a very different way of doing it. So it's really going to be a case of trying to find the right supplier for the right job and working with them through the process. And just kind of moving on from that, the final tip on the manufacturing side is knowing what your scope of works is. So some suppliers can take on different elements of design. They need different bits of information at specific times. So understanding what that process is, how the supplier works, what they will do, where they take the information from, what they need from you as the engineer or what they need from the architect. It's often going to come as a surprise later in the process to find that there's more information needed, or you spend a lot of time doing a lot of models and details and the supplier wants to do something different. So again, getting that engagement and establishing that scope of works is really critical for the engineer to get the most out of the project. And as I said, quick note on timber frame. So this is something that I'm seeing more and more now. Like AS 1684 covers kind of class 1 buildings, and that's where a lot of our timber frame has been going into over the years. But we're seeing more interest in particularly multi-residential, in schools, in aged care, that sort of building. So we see a lot more opportunity there. There are the 3 kind of major nail plate providers, Mytech, Pride, Multinail, definitely can support with engineering and advice. Certainly coordinating around other materials is often a real headache there. But if I look at a couple of examples that I've seen, if you want to kind of get something more cost effective out of your timber frame, simplifying geometry is massive. So if we look at the roof comparison at the top, I don't know exactly what that would be, but it may be 30% of the roof elements in there are prefabricated, and a lot of those are kind of handmade, individual sticks delivered to site to frame out those. Whereas if you can build something more like the one on the right, 90% of that could be prefabricated. So there's a lot of savings to be had there, particularly when you get out into more of the commercial buildings in kind of keeping things simple. And the bottom example, regular rectangular raked walls versus raked walls. So the rectangular walls flow really nicely down the process, down the the factory line, whereas raked walls with an angle have to be built offline by hand often. So, designing the building around those to make sure that we're again able to make the most use of the automated lines where possible. So I'm going to design for assembly now, or how to think like a chippy. The big thing here to bear in mind is it's about time. So installers will price on the basis of how long they need to be on site. That's not only labour, but it's also hire of scaffolds, cranes, the likes of propping. Faster they can get done, the cheaper the cost is. So always got to bear that in mind when you're thinking about design for assembly. So the first tip is minimise the hook time. So the faster you can get the crane unhooked and going to pick up the next panel, the cheaper it'll be. So simple things like pre-installing brackets or pre-installing props on the panels, simple bearing details so that you can just drop elements onto each other is so much faster. Here's an example of a beam column detail. The one on the left having embedded steel plates, a lot of bolts, dowels, whatever, fitted through there. Challenging for tolerance, and then you need to fit a number of those in before you can get the unhook the crane. Whereas the bearing detail on the right hand side, you can drop the beam in, put a couple of screws in to secure things, and then you're away and picking up the next one. So that sort of simplicity of connection is much preferred and makes a significant difference to the install costs. So again, tip number 2 is, so you've made your lifts faster and minimize the number of them as well. So again, the larger elements you can put together, the better. This is an example of a building where all the CLT panels were very narrow. By literally doubling the width of the panels, we can halve the number of lifts, half the install cost practically. There's a certain amount of cost in just lifting up every panel. That tends to be how they're priced. So if you can reduce the number of panels, then you're reducing the cost and the time on site. Makes significant savings. Tip number 3, tolerance is a massive one. Timber can be fabricated to within a couple of millimeters. Typically, concrete isn't fabricated that accurately. Steel can be fairly accurate, but we need to be aware of all these differences. Particularly, water can impact these. If we are relying on bearing between timber elements, you need to consider the gaps between them. I'm a big fan of actually drawing tolerance in my detail, so knowing that elements aren't going to meet there exactly to the millimeter and be touching, I think, is important in some cases. So there's a couple of examples of some projects I've been involved with where the building crept out. Set downs and things didn't quite align with the panel on the right. Needed some packing and some remedial work to go on there. The one on the left was a half flap joint, which was fabricated out of tolerance, but there was a reliance on those 2 elements bearing, which then needed some remedial works and details on. So again, I think understanding tolerance and physically drawing that in your details, I think is going to be really important to make sure that we don't end up with issues like this on site. Interfaces with other materials are always where things are delayed. I was lucky enough to spend a day on site with an installer that I've been working with over a number of years. Pulled the hard hat and the high vis on and went to be a labourer for a day with them. And it's amazing how fast, when it's timber elements, so they can install things. The second it all kind of meets a concrete element or a steel element, that's where it all seems to go wrong. Making sure that models are fully coordinated, shop drawings are fully reviewed, that you've considered all the different elements. How are they visual? Which one comes in first? Which are easier to modify. Usually it's the timber that's the easier one to cut and modify on site if things don't match. But understanding where those kind of gaps are to fill in. And then tip number 5, fixing intensity versus capacity. Most fabricators I speak to, installers, they're far more happy to install a fewer brackets at greater centers than they are to put lots and lots in. There's a certain cost of just installing a bracket. If you can put in half the number of brackets that have double the capacity, often that's a far more cost-effective solution. I just want to run through some case studies, just because I think sometimes we learn better from our mistakes than the things that went well. And these are some from early in my career where I learned a lot. This was a learning around manufacturing. This was an aged care facility in Melbourne. This was just after I started work at XLAM. We'd spent a lot of time designing this aged care facility. And I got a call from the CEO telling me to get on a flight to come over to New Zealand where we were manufacturing, and to come and see what a mess I'd made of it. But there's a lot of panels in there, a lot of very small individual elements. Some of them were quite flexible. Some of the panels had a lot of holes in. So, one of the first learnings from that was, there's too many small pieces in it. There should have been a design that look to utilize the CLT panels where they're suited, and then maybe substitute in some other elements for the smaller pieces, not trying to make everything purist. Another one was the optimizing these openings. Like some of these panels kind of got turned into Swiss cheese, were very, very difficult to lift, to move. They become quite flexible. So there was certainly some learnings there in how we could have done things better. We could have worked together with the architect early to optimize around the material rather than trying to make the material fit the design. So there was a lot of learning there, and I think that's probably the best 4 hours I've spent learning timber in my life. In a way, I learned more there, sitting watching the guys on the machine, asking questions, seeing why things were challenging or why they were having to stop, and where all those sort of challenges were. Highly recommend anyone getting out there and trying that, and spending time in a facility if they can. The final outcome looked really nice, and I think it was a great project, but certainly a lot of challenges in the manufacturing. An assembly case study. This is a project I worked on in Tasmania. So there was a whole development on a site of accommodation and community buildings and a restaurant. So we did a lot of work early in the process, looking at different ways to manufacture and assemble the project, what was going to be most cost effective, whether it was larger panels but simpler to manufacture, or smaller ones with a lot of kind of sub-assembly. So each of these units was repeated 15 times, so it was really important to look at all those details. But the actual design ended up being a kind of call it a, I don't know, sort of armadillo kind of creature with lots of kind of windows looking out to the view, with a lot of thin walls. But yeah, certainly made some mistakes on this one. One was, there was a steel frame supporting all the structure, which was designed by another engineer, but because we didn't have the overall kind of control of it, we ended up with a cantilever steel structure that was a lot softer than we anticipated. The CLT in the end provides a lot of stiffness in the final case, but during that sort of construction, we found that the cantilever deflected, left a lot of kind of gaps, and that had sort of knock-on effects on tolerance as well. So, certainly a mistake there in not communicating adequately with the base building engineer, and not necessarily understanding that aspect of the design and what that would mean in the assembly piece. But another one there was looking at the kind of thin walls, which were designed to sort of hang off the edge of the slab and provide an overhang at the bottom and a parapet at the top. which looks great when you draw it. But again, that what I talked about earlier about drawing the tolerance in your detail, it's very hard to get that junction, particularly at the top, to meet exactly. So that's another one which I would have done very differently. I would have put a different panel at the top and had the wall sit under the roof and fixed it very differently. There was no margin for error there, and there's a lot of kind of gaps and things which had to be kind of filled, and there's a cornice piece which wasn't part of the design which had to go in there to sort of cover up some of those sins. So again, having a appreciation of tolerance, I think, is really critical. But when it does go right, this is another building on the same site. It can make huge savings. So this was a restaurant building, so it had a kind of timber coffered ceiling, a roof structure initially, and that was, I think, over 600 pieces we worked out that was going to end up being, and that was going to have to get fabricated on site, significant amount of time and sub-assembly work to go on. So we came up with an idea of actually utilizing the CLT panels as a folded plate as the spanning structure. So not only are we reducing the amount of material, reducing the amount of lifts, simplifying the construction, made significant savings on this element, and it's ended up as a really beautiful space. If anyone ever goes to Hobart and wants to kind of take a little detour out to Sorell, you can have lunch in there, and it's an absolutely stunning spot overlooking the cherry orchards. And another bonus of the structural system that we used in the end was that we completely removed all the columns along the edge of the balcony, which gives you this sort of unimpeded view down to the water. So what are the case studies teach us? I think I've been kind of honest that DFMA is a journey. We can't expect to get it all right from the start. And I'm just encouraging anyone that's interested in this, anyone that's doing a project, is to take every opportunity you can to get a visit out to a site or a factory, particularly if it's something you designed and worked on. You will learn so much there about it that will feed into your next project. And don't be afraid to ask for feedback. There's I do a lot of work with installers, and they like to grumble about things, and they like to complain that this detail was challenging to install, or there was no tolerance here, or this could be done better. But unless that feedback's getting back to the designers at the start, then we're not learning. So encourage anyone involved in these projects is to make friends with everyone downstream in the process, and be open to feedback. But knowing that when we do get it right, we can deliver much more cost-effective structures, and we can really make timber a viable option for a lot of buildings. So just in summary, sort of kind of touch briefly on sources of information. Again, I'm here representing Wood Solutions, and if you want to go take a look at their website, they have a lot of really great information on there. The technical design guides are invaluable. There's so much information there. The case studies, there's opportunity to find suppliers, to connect with experts in the field, and look up information on all sorts of things. So that's a really great resource. Certainly there's a lot of suppliers out there. I apologize, this map I put up I drew for a client a few months ago, I think it's already out of date. So there are more and more people coming online. There are people changing, people growing capability. And certainly in the sort of lightweight timber framing space, in that sort of green color, there's a lot more people that are coming online in this every day and building their capability. So it's a pretty exciting time for the timber industry. But if you want to know more, again, go through the likes of Wood Solutions or other peak bodies to get connected, and to learn more about what's going on. So just summing up, DFMA, if we can employ that thinking, that methodology in our designs early, we can make our buildings more cost effective. So the things I want you to take away for the manufacturing side, you're thinking volume through the factory. For the assembly side, you're thinking speed. How fast can I get this thing installed? So if you can kind of remember those two elements, you're going to go a long way towards making your timber building much more cost effective. Collaboration is so vital for timber. We're still relatively early compared to concrete and steel in terms of the understanding the market capacity. So we really need to get out there and speak to suppliers, speak to installers, speak to representatives of Wood Solutions and get that information and collaborate. We can't design in silos and think that the material will be able to fit the design. You really need to fit the design to the material up front. Take every opportunity you can to get hands-on with the process, whether that's a site visit, whether that's a factory tour. I encourage everyone to get out there and see it, and to keep treating DFMA as a circular process. So everything that you learn, make sure it gets fed back into the next process, gets passed on to others in your team. We all help to grow this together. Just remains to say thank you. My name's Nick Houston. As I said, we're here representing Wood Solutions, also run my own consultancy, and a small plug for Timber Dialogue, which is a completely free to join group that I run with a couple of friends, where we catch up regularly and pick a topic about timber and have a chat. So there's plenty of really passionate people out there that are open and willing to share information. So please feel free to reach out to Wood Solutions or myself. We'd love to see some more timber buildings. So looking forward to some questions now. Thank you.
Thank you, Nick, for a great presentation. As always, it's now your turn to get involved. If you could ask Nick questions via the chat box, and just put your name there as well. Thank you to everybody that put forward questions whilst registering. We might start with a couple of those. We have a question here, Nick, that's coming asking, would fire rating and acoustic rating affect the size of timber sections? Thanks, Nick.
Yeah, look, it's obviously it's a really critical part of any timber design. The wood is a lightweight material, so when it comes to things like acoustics, often need to add in additional material, whether that's putting in dropped ceilings or build ups on top of slabs to sort of, particularly when you're looking at multi-residential, those areas where you do need to achieve higher performance. So that's obviously one thing. It doesn't tend to affect the size of the timber so much, but definitely fire will impact the sizes of your members. We use either a combination of charring through the timber through AS 1720 Part 4. You can do calculations. When it comes to things like CLT, the specific manufacturers have their own kind of char data and things that they can provide. So you can use the timber to fire protect itself. So in some of those cases, your design may be governed by the fire case itself. You can also use supplementary materials like plasterboards and things, and there's some newly done testing on rock wool to protect your timber as well in external facades. So using a combination of other materials as well is often beneficial, particularly for something like an apartment or things where you are looking for a kind of high level of acoustic and fire performance. Often we're finding we need to use supplementary materials to get those performance levels that we need for those areas.
Thank you, Nick. Nick, we've had a question that's coming from Kevin, who's watching in Queensland. Good afternoon to you, asking, Nick, can you build band beams systems just like concrete but in timber? And how about drop panels? Thanks, Kevin.
Yeah, look, it's certainly something that we've started looking at more. There's a really great example that was done a few years ago up in Maryborough in Queensland, a fire station up there. So it was utilising CLT panels as larger, wider beams rather than glulam beams, which tend to be narrower and deeper. So the reason you might want to do that because you are kind of pushed for head height and things. The CLT panel kind of, obviously anything that's wider and shallower is less efficient from a pure bending point of view. So you need more of the material, but the utilizing larger panels has obviously some benefits in terms of reducing your overall structural floor-to-floor height. So certainly there's a few projects around the world that are looking to utilize systems like that and generate more continuity in our structural design. We tend to a lot in timber design, things are simply supported spanning from A to B, but if we can start to generate more continuity into our structures, then we can use the timber fiber more efficiently and reduce sizing.
Thank you for that. Questions coming, Nick, from Robert, and Robert's here in Victoria, asking Nick, what's the biggest mistake engineers make with efficient timber design?
I think one of the big one, and I obviously focused on it a lot during the presentation, but it's just reinforcing that we need to engage with the supply chain. I see a lot of designs that come through that haven't considered the material, and if you're trying to fit the material to the project, that works with something like concrete, which is sort of free flowable and can take up a lot of shapes, whereas in timber we're limited by sizes, capacity of the suppliers, what grades and things are available. So I see a lot of effort that's sort of wasted sometimes where people are putting sizes, grades, things that don't exist, and that sort of just creates a lot of confusion and rework that comes later, and that can have impacts on architectural spatials and things like that. So the biggest problem I find, I think, is not engaging with the supply chain and understanding what's possible. And there's plenty of wonderful suppliers out there that would love to talk to you that have lots of really great information. Organisations like Wood Solutions and things will offer a lot of seminars and webinars. There's a number through Engineers Australia that'll be on YouTube as well. So there's a lot of really great information out there, and it's really important when it comes to timber buildings is that we're across all that stuff, because it's not as the supply chain isn't as well worn. There's less operators out there who are capable of doing things and less sort of flexibility. So while this industry is still establishing, we need to kind of design more around the current capability than design something and hope the capability is there to match.
Thanks for that, Nick. We've had a question come in about existing timber houses from Ross in Queensland, asking you, Nick, how can efficient design be utilised in building extensions to existing timber houses? Thank you.
Certainly that idea of vertical extension is really is a key one. I think there's a lot of opportunity to extend upwards, particularly as we get into sort of more densified suburbs. When we're probably have a query or two every month about people that want to put extra levels onto a house or onto apartment blocks, and timber's a great solution for that because it's lightweight, it's easy to prefabricate. The biggest challenges there are around that integration piece. How quickly can you put the new structure on and get things watertight before you have to so you don't kind of impact any of the structure below. So there's certainly a kind of few examples around. I'm not aware of too many in the domestic space, but certainly we've got one of the tallest ones in the commercial space, which is 55 South Bank Boulevard, which is a 10-story hotel extension on top of an existing concrete building. So I think vertical extensions and timber is a great opportunity, and I know there's a lot more interest in those sort of air rights projects now that are as we're trying to densify our suburbs. So I think that's a really great opportunity.
Thank you for that. Question has come in from Robert, watching from New South Wales, asking you, Nick, how can the same ideas be applied to residential construction, houses and apartments? I think you just touched on that a little bit before as well. Thank you.
I think, yeah, I think that kind of housing space is obviously a really kind of hot topic at the moment. We have a lot of government incentives, state and federal, um, trying to kind of incentivize development in this space. I think the biggest thing that we could do there is to try to standardize uh, different styles of buildings. In New South Wales, the New South Wales School Building Authority, they spend a lot of time standardizing classroom blocks and things, and designing. We call it kind of kit of parts approach. So you could have this interchangeable systems, but you knew that every classroom was going to be a specific size. You knew that many of these blocks were going to be a specific size. So you can, as a manufacturer, you can then start to optimize around that. Like when you're having to deal with prefabrication, modern methods of construction and things, and every project's kind of unique. There's so much kind of time and effort that goes into that. It's really not very cost effective. So what we'd love to kind of see is sort of more standardized solutions around that. Not saying that we all need to live in cookie cutter houses that are identical, but if we can be starting to standardize components of those, or systems within there, then that manufacturing industry can then start to grow with confidence, and start to develop specific products and solutions that are very tuned to those elements, and then that's where costs start to come down. Economies of scale start to play into it, and we can really start to develop things a lot more cost effectively. It's just we seem to be in a habit at the moment of every project's a prototype. It's designed and built once and never to be used again. So if we can, that sort of institutional level of client, government, or otherwise, we need to invest in kind of making things more standardized so we can improve productivity.
Thank you for that, Nick. Margaret, also from New South Wales, has sent through a question asking you, Nick, what type of buildings can't use timber construction? Thank you.
I wouldn't say there's necessarily any one type of building that couldn't use it. I think there are certain areas where it's better suited than others. I think certainly, if you are looking to use timber outside, we need to be very, very specific and careful around selecting the right materials, the right treatments, the right timber species, make sure the details right. So certainly possible to use outside, and there's plenty of examples of some wonderful buildings that have really stood the test of time. We need to be very specific about their maintenance regimes and how we deal with that. But I think we're clearly not going to be building fully timber 50-story towers, but that's not to say that timber couldn't form a part of that. So we're seeing more and more people looking to hybrid buildings. So using timber for components where it makes sense. I'm thinking of buildings like the Atlassian Central Tower in Sydney, which is currently going up at the moment, which is a large hybrid tower with a sort of concrete core and what they call these sort of mega floors at every fourth floor, which is a sort of steel and concrete one, and then they have sort of 3 timber levels, which they call the habitats, and they just kind of slot into into these sort of shelves within the overall building. So by doing that, they're trying to decarbonize the building, trying to offset some of the concrete and steel that would be used by replacing some of that with timber. So I think as we start to push things, I think I'm all for the appropriate use of timber and putting it in the right places, where it suits for structural characteristics, for fire performance, for durability, and then we have steel and concrete and other wonderful materials that we can add into that. So we're certainly seeing more of a drive towards hybrid buildings as we sort of increase in scale and complexity.
Thank you for that. We've had a great question come in from Garth. Good afternoon to you. Asking you, Nick, have you done any volumetric modular construction versus panelised, i.e. where a room is constructed in 3D, fitted out, and then stacked and connected like Lego?
It's that the modern methods of construction conversation is is in full force, particularly again in housing. You can hardly go a week in the newspaper without a state premier or a government minister, telling everyone it's the solution. And I think, that volumetric style of project certainly has a big part to play in that. It is done less commonly with timber at the moment. A lot of our volumetric buildings in Australia are done with steel, but it is done a lot overseas. There is a company in Melbourne called Modscape who's building volumetric modules out of timber, so a combination of CLT floors and kind of lightweight framing walls, and they have a really impressive robotics line there. So if anyone wants to look at Modscape, there's some wonderful videos and projects that they're doing. I think certainly it will suit specific locations really well, where you have maybe limited access to trade, so more remote areas. I think it becomes very, very strong solution. I think there's also the potential to kind of have hybrids where you potentially use the volumetric solution for the more heavily serviced areas, which take kind of longer to put together on site, and then maybe you have a kind of flat pack system for other areas. So there's certainly a lot of solutions around there, and I think that volumetric one will definitely be a big part to play in the future as well.
Thank you for that. Questions come in from Ricky, asking you, Nick, I'm just curious, with the longevity of a timber structure when compared with a composite structure, steel, concrete, particularly under the harsh Australian climate, still be sustainable today? And I might tie that in with Ian's question, which is, are timber structures very susceptible to insect and or rodent attack in Australia?
Yeah, it's a really good question, and I think that it's one that we collectively as engineers need to work really closely on when it comes to timber. I actually gave a presentation a few months ago, which will be somewhere on the Engineers Australia YouTube, where I sort of look in a little bit more detail at durability, because I know there's a lot of questions around that. But it's about kind of keeping the timber dry, and it's about keeping the timber free from insects, and there are a number of different ways to do that. But it's also about the robustness of those protective strategies. So it's about maintenance of membranes and facades. It's about kind of making sure that there are secondary opportunities for water if it gets into a structure to get out again. So we're not designing water traps into our details, into our structures. So I think when it comes to timber, there are plenty of examples around the world of buildings that have been happily stood for hundreds, if not thousands of years, that built out of timber. And the common thing is that they're all well detailed, well maintained, and they all have the right characteristics to make sure that they're shedding water, that they're protected from insects and things. So when we want to deal with a timber building, it's making that durability strategy really central to your design, and that's something that I think we all need to bear in mind when we're doing these. Is that needs to be a very overt focus. It's not kind of like a concrete building where you look at exposure class and design a cover on it, and then you don't need to kind of worry too much more. Timber needs that overt, specific response to durability, and if we do that right and get the right advice on from industry, from suppliers, then there's no reason that they can't last for hundreds of years.
Thank you. Talking about durability, a great question from Salman asking you, Nick, are there any durability concerns using laminated products externally? What design life in years would you expect?
Again, it needs a very specific response. There's some really great guidance on wood solutions. There's some world-leading research done by CSIRO, a few years ago. So there's a timber durability and design life guideline on wood solutions, which looks through different species, and provides hazard maps of Australia based on climate, based on potential insect attacks and things, and gives advice and guidance on design life. I think specifically with the laminated products, there's certainly the adhesives that are used these days are very very robust. They have a good amount of robustness in them when it comes to weather exposure. So it's more around the right choice of the species and treatments and efficient kind of detailing. There's a fair amount of guidance in AS 1684 on that domestic sense in terms of how we protect it. There's not a lot of overt guidance in 1720 when we look at larger structures. So there are some excellent resources around the world. There's some great ones out of Canada, out of the UK, which gives some more practical guidance on how to design those and what are appropriate species and details to use. So yeah, very critical if you're considering an external structure is to make sure that you've got the right specification and species. That's the kind of number one consideration.
Thank you for that. Nick, question from Monty. Monty's asking, CLT looks expensive. Where does it come into its own? Thanks, Nick.
Yeah, look, it can be an expensive material on its own. I think that it certainly has characteristics that suit certain aspects over others. It's probably not designed for domestic single-family houses unless you're doing something very very special, or that you are kind of you're willing to pay a premium for a kind of premium product, and that's I guess where it fits in. So there's some wonderful examples around the country of people that use CLT for passive houses, for high-end residential buildings, and they've utilised some of the unique characteristics of it to create interesting architecture. It's not the sort of product I would use in a kind of fairly standard two-story house. I think where it starts to come into its own as we get into more commercial buildings, into townhouses or low-rise residential. So I think there's a strong opportunity for a combination of kind of lightweight timber frame walls and CLT floors for apartments up to maybe 4 to 5 stories. Certainly overseas, Europe, US, Canada are building all their apartments like this. So they don't build a 4-story apartment out of concrete; they build it out of timber. Whether that's lightweight framing and CLT or floor cassettes or something, it's much more common over there to do it out of timber. So there's a lot of opportunity in that space where I think engineered products and prefab timber will kind of come into their own in the next few years.
Thank you, Nick. We've got time for a couple more questions. We've got one that came in from Subramaniam in New South Wales asking you, Nick, what are the methods used to fireproof the timber structure?
So I guess we would tend to do that again through charring. So designing the timber to be able to burn. So it has a fairly predictable char rate that's been established through testing over the years. So you can calculate the level of fire resistance based on how far through the section that the fire will char, and then calculate based on your fire design loads. That you still got enough capacity to support the structural loads, or you're using plasterboards or other products to help supplement that.
Thank you. And Christopher in Queensland asking, and we just reworded this question a little bit, Nick, is if we're not confident in the design of timber, where should we focus our design scope? Thanks, Christopher.
I think that is a really important question, because when it comes to timber, I think this is still relatively new in the scale and complexity of the buildings that we're building now. Where we were 15 years ago in Australia, we'd never built we never heard of CLT really. So we've come a massive way in the last 15 years. I think if you are interested in it, it's about making sure that you are informed about what's possible. And it's about not being afraid to ask questions of people and take on advice. I think there's a lot of really great people out there, whether they're suppliers or working for peak industry bodies or builders, installers, who will love to give you benefit of their experience. So don't be afraid to ask for advice and support on that. And if you need to get support or find suppliers to do specific areas of design, whether that's designing connections or looking after moisture plans, durability, that sort of stuff. Don't be afraid to kind of ask those questions and look for that support from industry.
Thank you, Nick. And we will have to close shortly, but I just wanted to ask you, Nick, we've talked about a lot in this afternoon's webinar. So I wondered if you could just share with the audience for a couple of minutes the key takeouts from your presentation, and also on behalf of Engineers Australia, any advice you give to our young engineers that are coming into this field. Thanks, Nick.
Sure, thank you. I said I've been really lucky in my career to have sort of found this niche, and I started my career at a university having done a couple of modules on timber over the whole course, and then it just was sort of a quirk of fate that I started working on CLT building in London as my first project, and it quickly became a real passion for me, and I've loved kind of being in this space. But I think it's about being kind of inquisitive and hungry for new knowledge. There's a lot of really good information out there, whether they're webinars, there are technical groups, there are organisations like Wood Solutions, there's opportunities to go and visit sites. There's opportunities to go to factories, even out into the forestry. So if you're really kind of passionate about this, I would highly advise taking all those opportunities to get out and see those places and speak to these people. There's a lot of really good conferences come up. I don't know if anyone on the video was at the World Conference for Timber Engineering in Brisbane last week, but that was really inspiring, and a lot of amazing work going on around the world there. And I think understanding that process right the way from from the forest all the way through to site, and then even into service and maintenance, just looking for every opportunity you can, and working with the suppliers to make sure that your designs are well tuned to what they're capable of delivering.
Thank you, Nick. Thank you, everyone, for joining me for today's webinar discussing efficient design for better timber buildings. This session has been recorded, as always, so you are still able to access the footage on the Engineers Australia's YouTube channel and on EA On Demand on our website in a couple of weeks' time. Please join me once again in thanking Nick Hewson for his time and input today. Doing the Q&A on your own, he did a wonderful job. I'd also like to thank Engineers Australia's industry partner, Wood Solutions, for their ongoing support. As always, if you could complete a short feedback form, which is linked in the description box below, to help us improve and plan for future sessions. Thank you again for joining us, and I look forward to seeing you at our next Industry Partners event. Thank you and good afternoon.